Okay, let's find or derive the trig function derivatives for tangent and cotangent. And in doing so, we're going to reinforce our understanding of the quotient rule, as well as use the derivatives of the sine function, which is cosine, and the derivative of the cosine function, which is opposite sine. Okay, so tangent. The tangent of x itself is a quotient function because it is made up of sine of x over cosine of x. Okay, let's take the derivative using the quotient rule. So f prime of x, low d high minus high d low all over the square of what's below. So that's cosine of x, quantity squared. Usually we write that as cosine squared x, but again, same thing. Okay, so now, up top, I've got operators there, which tells us we need to do the derivatives here. So I've got cosine x. Now I'm taking the derivative of the sine of x. The derivative of sine is cosine. So I've got cosine x times cosine x minus sine x. Now the derivative of the cosine x is opposite sine x. And again, everything is over cosine squared x. So I've got cosine x times cosine x, then I've got negative sine x times negative sine x. Okay, which means I've got cosine squared x plus sine squared x. Hopefully that rings a bell. Cosine squared of x plus sine squared of x is one of the fundamental Pythagorean identities for trig function. That equals 1. So I've got 1 in the numerator over the cosine squared of x. Okay, and remembering back to trig, 1 over cosine is secant of x. So that means 1 over cosine squared is secant squared. Okay, and what does that mean? That means that the derivative with respect to x of the tangent of x is equal to the secant squared of x. Again, the derivative of the tangent of x equals the secant squared of x. Okay, let's try it again. It's going to be very similar work, but this time, let's do the cotangent. Okay, and again, cotangent itself, f of x equals the cosine of x over the sine of x. We've got a quotient. Again, cotangent is one of the quotient trig functions. Okay, so the derivative, f prime of x equals low d high minus high d low all over the square of what's below. So again, that sine x quantity squared, I'm just going to write it as sine squared x. Okay, so again, operators in that numerator tell us we still need to take a derivative. So I've got sine x times the derivative of the cosine, which is opposite sine x, minus the cosine of x times the derivative of the sine x, which is cosine x, and again, all over sine squared x. Okay, so again, operators are gone in that step. The derivatives are done. Let's clean it up. I've got sine x times opposite sine x. That's opposite sine squared x. I've got opposite cosine x times cosine x. That's opposite cosine squared x. And again, we're over sine squared x. Okay, so in this one, we've got negative sine squared and a negative cosine squared. So let's factor out a negative sign in the numerator. Once we do that, I've got sine squared of x plus the cosine squared of x And again, this is over the sine squared x. So similarly to the derivative of the tangent, we end up with a sine squared of x plus a cosine squared of x in the numerator once we factored out that negative sign, which tells us then we've got -1 in the numerator over the sine squared of x. And going back to our trig, 1 over sine is the cosecant of x, so 1 over sine squared is the cosecant squared of x. So in this case, don't forget about the negative sign. So we've got the negative cosecant squared of x. And again, what is that? That is the derivative with respect to x of the cotangent function. Ran out of room here. So my derivative with respect to x of the cotangent of x is equal to opposite cosecant squared of x. So we just derived the derivatives for tangent and cotangent using the derivatives of sine and cosine.